Mora's fires have destroyed Greece's largest migration camp, leaving nearly 13,000 people without shelter. Could this have been prevented? Through an extensive brainstorming with the DIC, we understood that the settlements currently are impacted by climate change and also face the issues of having an environmental impact on the surroundings if not managed correctly. Imagine if you could choose any point on the map and find out about the environmental conditions from 10 weeks or 3 years ago. Not only can you visualize the changes in the environment, but you can also predict how the future will look like if the resource depletion continues to accelerate at the same rate. Our solution resembles Google Maps, but is much more powerful than that. You can pick a location on the map with an established camp. By entering the amount of people and the operation time, you get a visual representation of the past, current situation, or the future environmental conditions of the region. Further, you can choose to visualize how the vegetation, rainfall, temperature, or soil quality looks like at a specific moment in time. That will help to understand how about which resources need to be provided. Do people face a drought or rather the opposite? Should we prioritize the wood for fire or drinking water in this area? The next important feature is a time scaler. It shows how the area has looked like before a refugee has been placed there, or based on the predictors, give an estimate if people will be hosted in the camp in the future, how it might look like. That can further be integrated with a graph that shows how it can be in the past and how it might develop over the future. A simplified traffic light will indicate how it is likely to place more people there or whether their capacity is met going forwards. We'll be training a machine learning algorithm with the various satellite data specific to the filters vegetation, soil quality, temperature, and rainfall. The results of the model will be validated by the DRC questionnaire, but a project database will be needed to be created using an application cloud-based. As you can see here, there are many studies carried out which use satellite data to access the land use and to visualize how the vegetation has been changing over the years. But even the concept of training an algorithm to interpret satellite data is not out of the blue, such as the sea surface temperature satellite technology. Satellite imagery is open source, easy to download, and has data prevention function in combination with an API. Using simple scripts such as these ones shown here, we can soon start training the algorithm using the data available via the satellites. To validate the results of the algorithm, we need the data from the DRC. Thus, we would like to partner up with them. In the next step, we're extending the algorithm to the next implementing feature, forecasting and predictive modeling. The end goal is to reduce the number of trips to the camp itself, use the data from the previous questionnaire, visualize the changes in the environment to be able to predict why and how it could have been prevented, to better plan the placement, capacity, and lifetime of a settlement in the future.